All right. Hello, everyone. Let's go ahead and get started. Wow, my very first TGIK. Man, I have been thinking about this for a really long time, right? Like, I joined Heptio in 2018, and from like the first time they started talking about TGIK, I was like, I want to be on TGIK. So, finally happening. Super thrilled to have all of you here. Welcome, everyone from all around the world. I see folks from, let's see, Tehran. Wow, that's a long ways away. I wonder what time it is there. Hey, Jed from Boulder. Good to see you, man. Eric Smalling. What's up, buddy? Andy Goldstein, thanks for being on. I saw Vince earlier. So super thrilled to have everyone here. Today we're going to be talking about Cluster API, right? And I know that there's been a couple episodes on Cluster API beforehand, but we're going to be doing an update on sort of where Cluster API is now. And then we're going to show off some new features, or, well, newish anyway, features that haven't been shown here on TGIK as far as we know. Now, before we do that, though, let's talk a little bit about like what's been happening in the Kubernetes world, right? So let me pull up some links here real quick. All right, here we go. And we'll open our window. All right. All right. So before we get started, I have a few, sort of like news items I was going to share with everyone pertinent to the episode here on Cluster API. We have new releases of Cluster API and the Cluster API provider for AWS that just happened earlier today. So let me pull that up. So the Cluster API provider got released to 0.3.13. Mostly bug fixes and a few new features. One really cool feature that I'm going to show you later here is this clusterctl describe cluster command, which is super cool. Love that new command. Told some of the other developers in one of the Slack channels that I love it. So I think you guys are really going to like it if you've worked with Cluster API at all. This is a great way to sort of get the status of the cluster, right? So we're going to look at that here in just a moment. But so new release here, you can use clusterctl upgrade to upgrade the Cluster API components on your management clusters, which I will not do on this show, just for the sake of keeping things, relatively sane, so that the stuff that we're going to demo later actually works. But in addition to this release, we also had a new release of the API provider for AWS. So now bumped to 0.6.4. So if you're using Cluster API with AWS, you might want to take a look at that. So a few other things of note, by the way, and I'll be periodically looking over here on the side of my screen because I have live chat running over here. So making sure I'm not missing anything. Hello to more folks. Thanks for joining late in the UK there, Nadir. All right, so a few other things. If you aren't familiar with KubeAcademy, this is an awesome website. It is sponsored by VMware, but I'm not just mentioning it because it's sponsored by VMware, but there's a ton of free training here on KubeAcademy. And so I wanted to highlight that we recently released a course on Helm. And this is 10 lessons on Helm, including, like introduction to Helm, packaging, hands-on with the Helm tool, creating Helm charts, using templating, wrapping everything up. So if you are into Helm or want to learn more about Helm, this would be a great episode, a great resource. This, by the way, is a completely free resource. All you got to do is go out to kube.academy. If most of the courses don't even require a login, there are a few courses that are listed as like pro courses that have longer, more in-depth lessons. They require a login, but still no charge. It's all free. So have a look at that. Also, I was super thrilled to see this news from fellow TGIK host, Josh Rosso. Josh and a few other folks have been working on a book named Production Kubernetes, and Josh just announced a couple days ago that everything is done and the book is headed off to print. So that's awesome. I know what it feels like to have worked on a book and just like been slaving over it and working on content and reviewing it. And finally that day comes when the editor tells you like, hey, you're all done. Everything's good. We're shipping it off to be printed. It's like awesome. The only thing that beats that is when you get the print copy in your hand. So I want to hear from Josh and Alex and, wow, man, I remember who else is on there. Okay, Josh, Rich, Alex, and John. I want to hear from you guys when you get the physical copies of the books in your hand. Let me know if I'm right, if that's like one of the most awesome feelings in the world, right? Let me move my browser a little bit here, slightly off screen. Okay, cool. So that's awesome. And if you are signed up for, what is that, O'Reilly service? I don't remember the name of it. Anyway, that'll get you access to the books. You probably can get an access to a pre-release version of the book, as well as get a copy of it whenever later on. So have a look at that. And then this blog post just went live not too long ago, and by fellow TGIK host Paul. And I won't try to mangle Paul's last name, so you're welcome, Paul. So this is about using Harbor, which is a Docker a container registry, right? It's a CNCF project, using that as like a proxy for Docker Hub. The idea here being that you can reduce the number of requests that you're sending out to Docker Hub, since back in November, they started applying rate limits to Docker Hub. And I've seen various and sundry folks indicating, things broke when they started hitting rate limits. So using this as like a pull-through proxy sort of thing is pretty awesome. So I haven't had a chance to read this yet, but I really appreciate Paul sharing the link with me. I'm going to add it to my list of links. And don't be too surprised if you see it show up in the next technology short take on my site. So cool. And then another one that is definitely going to make it onto my next technology short take is this post from Michael Gash, which is a sort of a deep dive on etcd, but initially focusing on the list watch pattern in Kubernetes. So Kubernetes objects applying a watch against an object to see changes and events related to the object, so on and so forth. Lots and lots of great detail here. I am still in the process of reading the article, but I've already added it to the next technology short take. So it'll show up on my site with a link to it soon, which I think it'll be awesome. Definitely take a look at that. And then one other thing I wanted to bring to people's attention before we jump into looking at Cluster API and some of the new features is this CRD's website. CRD's custom resource definitions. These are documents generated from the CRD code. This gives you an example of one particular object. In this case, it is a Cluster API object. It's for a vSphere machine, which is the vSphere specific object that underlines the Cluster API machine object. And this gives you a breakdown of all of the fields. It's the schema, right, for the vSphere machine object, right? So it gives you all the fields, the expected values. You can drill into various parts of this, so on and so forth. Super handy and a lot prettier than kubectl explain, right? So cool. Now, with that in mind, then why don't we go ahead and jump into the content that I have ready for you guys. So we are talking about Cluster API today, and we're going to be looking at a few different new features in Cluster API. And I say new features in that they aren't super new as in like they just came out last week or whatever, but as far as we're aware, and we've done a ton of TGIK episodes, but we haven't talked about some of the new features that came out in V1 Alpha 3. And some of those changes just add some new features that really make it easier to perform certain types of operations around cluster lifecycle management with Cluster API. And so we're going to be taking a look at a few of these things today. I'm going to do it in a little bit of an odd order, I think, but hopefully it'll make sense. So we'll start out. First thing I want to start out with is this idea called a cluster resource set, or a CRS. And the idea here is when you apply a new, or when you create a new workload cluster in Kubernetes, Cluster API just handles sort of the basics, right? Bootstrapping the nodes and getting everything set up, right? And so I'm going to pull some of this up, right? So I'm gonna first, no, I'm gonna connect to my management cluster. My management cluster is behind an SSH bastion host, right? So, and then I'm going to switch over to that kubeconfig. By the way, that KTX tool, I am a huge fan of KTX. It is a fairly simple command line tool. I'll have a link in the show notes after everything's done here. It's from Heptio Labs, so it's still in the Heptio Labs GitHub organization. But it just sets the environment variable for kubeconfig in whatever terminal you're in, which means you could have different kubeconfigs in different terminals, right? I like it, but hey, you know, different strokes for different folks. But anyway, I have a cluster that I have defined in Cluster API using this management cluster. This is an AWS, as you might gather, and it's sitting in US West 2. And when we look at this cluster, we see that the cluster says provisioned, right? And if I look at the machines in the cluster, then I see that they say running. And so from this perspective, it looks like everything's good, right? And even if I run this new clusterctl version, and y'all don't laugh too much at my typing, okay? And let's see, this is taking a minute. Okay, here we go. Even if I run this is the new thing that I was just talking about earlier, is clusterctl describe cluster, which shows you sort of the state of the cluster of a workload cluster, right? One or more workload clusters. And so here I'm talking about workload cluster, which I have very imaginatively named TGIK 143A, because this is TGIK and this is episode 143, and this is the first one, so it's A. And it shows you the status. Now, by all indications, this cluster is like ready to roll. Get cluster shows provisioned, get machine shows running, describe cluster shows true, and everything's great, right? But we're missing something here. So if I go and I get the kubeconfig for this cluster, which is going to be called TGIK 143A kubeconfig, right? So, and then we know if you've done this before, you have to do this little dance here to pull out the contents of the secret. And then because it's base 64 encoded, we have to decode it. And because I'm running on Mac OS, I have to do a capital D. And then I'm going to put this into my kube directory as TGIK 143A. All right. And now I can do this. All right. So now I've switched my kubectl context, my kubeconfig, over to this workload cluster. And if I do a get nodes, what I will see is that they are going to report not ready. See, like that wasn't surfaced up in any of the other commands that we saw, right? Now, the reason they're not ready is because I haven't installed the CNI. There's no CNI plugin. So I could, of course, just, kubectl apply calico, whatever. But what's the fun in that? Let's learn something new. And so what we're going to learn new, and I haven't used this feature yet, so I'm going to figure it out along with all of you at the same time, is this idea of a cluster resource set, or a CRS, which would, among other things, allow us to install additional things onto a cluster or a group of clusters, a workload cluster or a group of workload clusters using Cluster API, right? Now, this is an experimental feature. As you can see on the screen, this is the Cluster API website, by the way, cluster-api.sigs.k8s.io. Great website. This is an experimental feature. And so in order for it to show up in your cluster, you have to enable it first. And enabling it is described here in the experimental features page. There's a couple different ways to do this. If you want to enable the feature before you set up a management cluster, like before you initialize it, right? Then you can just set the environment variable here and then run your clusterctl in it. You can also set it in the clusterctl.yaml configuration file. Wait a minute, Andy's telling me about clusterctl get kubeconfig. Ooh, I haven't used that one yet. That must be cool. That must be relatively new. Okay. Either that or I haven't been spelunking around enough in the clusterctl command. The Cluster API developers are like running away with awesome stuff here. for developers, this stuff, but for users, if you want to enable it on an existing cluster, which was my case, I already had existing clusters, so I needed to enable it. And you have to go in and edit the deployment for the CAPI controller manager. So I'm going to show you what that looks like real quick. I'll show you that I've already done that. So let me clear this and switch back over to my management cluster, and then kubectl. Okay, so I'm getting the deployment here, and if you'll notice here, I have already enabled the experimental features, right? And it's already restarted and updated the pods as well. So this is enabled on this cluster. If you haven't enabled it, then you need to go and enable it either before you enable the management cluster or by modifying the deployment afterwards. But once it's enabled, then we can go in and we can use a cluster resource set to install additional things onto the cluster. I got, just checking the chat real quick. I had somebody ask, how was the workload cluster provisioned by Cluster API? So this cluster in particular was provisioned by using, I used clusterctl config cluster to generate the YAML. And then this generated this file, which is the a complete cluster manifest for a Cluster API workload cluster, and with a single control plane node and a single worker node, and then just did a kubectl apply to that that YAML against the management cluster, and then it went off and created it. So pre-provision ahead of time. It's kind of like that whole cooking show thing where we show you all the pieces, then we say, now here's one that I prepared for earlier for you, right? So here's a cluster that I prepared earlier for you. All right, so we want to install CNI. We want to install Calico. In this case, I'm going to use Calico into this workload cluster. We don't want to have to do it directly. We want to do it in some sort of declarative way. So to do that, we're going to do a cluster resource set, a CRS, right? So a couple resources that I'll point out real quick, and all this is going to be in the show notes. So there's this page. This links to the Cluster API enhancement proposal for Cluster Resource Set on GitHub, which has a little more detail and some examples of what that looks like. And then I also found this blog post, which provides the example, basically exactly what I'm going to do here, but being done on vSphere using the Cluster API provider for vSphere. We're going to be doing it using the Cluster API provider for AWS. But the idea here is rather than having to manually go in and install a CNI after the workload cluster is provisioned, let's have Cluster API do that for us. All right, so now that I've set the context of what we're going to work on, like I said, I haven't done this before, so let's try and figure it out here. So I had in advance reviewing directions and all that. I have some files prepared for us. So first thing I have prepared is this config map. Cluster resource set is going to use config maps and other, I believe secrets. It will use that to apply stuff to the workload clusters. And I know I have some maintainers in the chat, so feel free to correct me if I'm not presenting this correctly. But this is the Calico YAML, which I won't scroll all the way through because I doubt that you're interested in that. And for that, I should probably just do this instead. But what we're doing is we're taking the content of the normal Calico manifest that we would use in like a kubectl apply, right? We're putting that into a config map, and we have this config map called Calico CRS config map. All right, whoops. All right. And then I also have an actual CRS definition that defines the cluster resource set. So it says, here's the name of the cluster resource set. Here's the namespace, which has to be the same as the clusters that it's going to match against. And then we're matching against a set of labels. So my clusters that have the labels CNI and Calico will then get this resource applied to them. Now here is where all the documentation that I have found begins to gloss over a little bit. So don't be too surprised if you see a blog post come out of this. But what I'm going to do is I'm going to add these to the workload, to the management cluster. And let's see if that does what I expect it to do. So first, my thought is that if I apply this to the management cluster, then I'll put the config map on the management cluster, and then I put the cluster resource set on the management cluster, and then the controller specified by the cluster resource set will go and get that config map and apply it to matching workload clusters. That's what I'm thinking, right? So we'll see if I'm right. So first we create the config map, and let's make sure that it's there. So here is the config map that we just created for the cluster resource set. And then we're going to create the cluster resource set. All right. Ooh, I got an error. Server could not find the requested resource. Okay. Well, that's interesting. Okay. Huh. Okay. Well, let's see. Do I have an error in my API version, perhaps? Let's see. No, that looks right. Okay. So let's do some troubleshooting here. Resources, mode, I don't have to specify because I think the default mode is apply once. And we have the metadata. All right. So let's see. This resource I could not find it. So let's see. kubectl get CRDs. Crap. Let's see if the CRD is there. I would think that it would be, but all right, let's see. Okay, cluster resource set, add-ons, clusterctl. Okay. All right. And if I look at I must have a typo here. Add-ons, cluster resource set. Yeah. Okay. All right. Well, see, I told you we were going to learn this together, right? Okay. Yeah, a few folks in the chat. Is the missing CRD? Well, that's what I was thinking too, right? But the CRD is there. We can see the CRD right here, cluster resource sets. So it's there. Calling webhook default cluster resource set. Add-ons, could not find a requested resource, right? Okay. Let's get back in here again. Seems Vince is saying the defaulting webhook wasn't installed. Okay, so I have no idea how to fix that. I did feature Fabrizio. I did enable the feature flag in. Oh, there's a webhook deployment too. Okay. So kubectl and is that going to be in the? Let's see. It's probably in the CAPI webhook system. So let's see. kubectl. All right. So CAPI. Yep. CAPI deployment. So CAPI controller manager. Okay. So let's do that. Let's edit this CAPI webhook system. Edit deployment CAPI controller manager. All right. Now this is good because I didn't see this in the docs anywhere. So that's the rate. Here we go. There you go. Okay. So you have to edit the deployment in the CAPI system namespace and the deployment in the CAPI webhook system namespace. All right. So that edits that, and we'll give it a minute. Let's see. Make sure that this has updated recently. CAPI webhook, CAPI controller manager, 11 seconds. That's probably the latest replica set that the deployment is managing there. Okay, so that looks right. Then let's try this again. Okay. So kubectl apply. Ah, that's much better. Okay. So now we have both the config map that contains the CNI manifest that we're going to have applied to the workload clusters. And then we have the cluster resource set defined that will leverage that config map. So now what we should see, okay. All right. Nadir's just pointing out in chat that generally you want to set the environment variable to enable this feature before you do the clusterctl init, which then enables this functionality in the management cluster right off the bat. But of course, again, I had a pre-existing management cluster, so I had to go do this. So probably don't want to normally go in and edit the deployment. Probably not the best approach, but that's okay. We're learning. We'll work through this together. All right. So kubectl get CRS. Let's see if that short works. Nope. Okay. Cluster resource set. All right, and then let's describe this. That double R right there is going to throw a lot of people off. All right, here we go. So this is a describe. There we go. All right, and it shows what's happening here. Now let's take a look at, we could probably look at some logs here. So, but let's just take a look at the workload cluster that I had deployed and see if it's already been applied. Oh, bam, check that out. Look, the nodes are already ready. So that means Calico is already running. So kubectl get pods A, and we should see the Calico nodes. Sweet. Okay, so there you go. Using ClusterResourceSet, I was able to define this. Now, the cool thing is that this was a pre-existing workload cluster, right? But because the label set matched, the ClusterResourceSet found the pre-existing cluster and then went and did an apply. And you probably saw on the screen a moment ago, we're talking about this spec mode apply once. Right now, if you read a little farther down in the text, initially only supported mode is apply once, right? So it's just like a one-shot thing. It'll apply this and then it's not going to go back and remediate it. Although if I recall correctly, I saw some conversations about them exploring an ongoing remediation of the cluster resource set against workload clusters, right? So cool. It worked. That's nice. Now, the other thing now that this is present, the other thing that will happen is any new workload clusters that I create that match the selector for the cluster resource set will then automatically get this. Now, it just so happens, conveniently enough, that I have the manifest for another workload cluster ready to be applied. So let me just make sure I haven't applied it yet. Don't think I have. We only have A here. All right, great. So we're going to apply TGIK 143B. And we're going to create a new workload cluster. Boom, off it goes. And that'll sit and run and cook in the background for a while we go play with some other stuff. And then we'll come back and check on it. And what we should find is that it should go all the way through to ready state without any further intervention on our part. Like we're not going to need to go install a CNI. It's going to take care of that because this manifest, and let me show you this manifest, did assign, notice, maybe I should do this in VI instead. So line numbers. Okay, on lines 6 and 7, we applied the labels to this cluster that will cause it to match the label selector that we defined in the cluster resource set. So it's going to create the new cluster, and then the cluster resource set's going to see it, and then bam, off it's going to go, which will be super cool. So I like Andy. He's like, magic. I need that GIF of, I think it's Shia LaBeouf, magic. Right. Okay. We have Steve Wade asking me in chat, KTX, is that my own alias? No, it is not. I mentioned this earlier. Let me pull up the link. It's here. It was a simple little project that some folks from Heptio created. And the idea here is that you keep each of your kube configs in a separate file. And then you just use KCX to select between the files, and it sets the environment variable for whatever terminal you're in, which is super handy because then you could have like 2 different terminals and 2 different kube configs set, right? Super neat. I love it. I use it all the time. All right. So we played around with cluster resource sets. We made it work. Cool. Now, while that second workload cluster is creating, let's talk about one of the other new cool features. Oh, and by the way, while it's creating, I should run clusterctl describe again so you can see the last time I used this, everything was done. But now everything is not going to be done. So we'll get a different output. Oh, no, that's not going to work. That's going to work. Okay. Yeah, so here we're still in the process of creating stuff, right? And so whereas before, if I go back and do A, it shows true, everything's up and running, all that kind of stuff. For B, it's showing that, hey, this is like, it's not ready, right? We're still waiting on stuff. And then it gives you why it's waiting. In this case, there's just an info message that we're waiting on things to happen, right? We're waiting on, in this case, it is in the process of creating the NAT gateways that are used by Cluster API when we instantiate a new workload cluster on AWS. So again, a quick look at clusterctl describe cluster there. Super, super handy. And again, that's part of the 0.3.13 release that just landed today. But while that is happening, I want to talk about one of the other cool things in V1 Alpha 3, which is the KubeadmControlPlane. So we have this cluster. We actually have 2 clusters, but I want to do this, and we're going to look at another object. So V1 Alpha 3 introduces this KubeadmControlPlane or KCP object, all right? And the idea here is that instead of managing the control plane as 1 node or 2 nodes or 3 nodes, what if we manage the control plane as 1 object? And so that control plane object then can have a set of properties, one of which is the number of replicas, for example. And this means that we can simply just scale if we want to go from 1 control plane node to 3 control plane nodes for redundancy, for high availability. We could just scale the KubeadmControlPlane object, and then Cluster API will handle the process of taking us from 1 to 3. And so that's super handy. Now, we could also scale back, but I think there's some concerns around scaling back. I don't remember for sure. I thought I remember seeing something. So if one of the maintainers can keep me honest here and put it in chat as to whether they don't recommend scaling back, if you're going from HA back down, I wouldn't recommend it, but you know, for testing and other stuff, it might work. So here we have the KubeadmControlPlane object. For our first workload cluster, we see a control plane object. It's initialized, true. API server is true. It shows the version, shows the number of replicas, so on and so forth. So let's say I want to take this cluster, this first cluster, which in my manifest was specified as one replica, right? And let's look at that real quick. So TGIK 143A. Here's the manifest that I used with kubectl apply to create this cluster. And if we go down here, starting on line 31, we see here's the KubeadmControlPlane object. And here's the name, which we just saw in the output. And here's the spec. And it's going to reference a machine template. It's going to give us a kubeadm configuration to bootstrap the cluster. And then here are the number of replicas, right? So I am going to take the declarative approach, and I'm going to change the number of replicas here, which will then trigger Cluster API to reconcile the desired state, which I have stated as 3 replicas, with the actual state, right? So, whoops. I am not a Vim expert, so don't laugh at me too much. All right. Actually, okay. Then I need to do this. And for the most part, you're going to see unchanged, 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 unchanged. That's because what is the actual state of the cluster matches what's defined. But you will note right here that this shows configured, right? And if I go and I run my get KCP, which is faster to type than KubeadmControlPlane, we'll see that it is now in the process of scaling up from 1 to 3 based on what I specified in the YAML, which is extraordinarily cool. All right, Vince is just adding in chat. Thank you, Vince. You can scale down, although features like automatic remediation are not going to be available on a single control plane node, which is fine. Like automatic remediation, meaning automatic updates of the control plane. If there's only a single control plane, then it can't automatically update that, right? So that's fine. That's expected. No big deal there. Another reason to run HA configurations. And we'll give this, let's see, this will probably take a couple of minutes to run. Yep. Okay. So it's still in the process. So while that is playing around, then we're going to give that some time. And we're going to look at the other cool thing that I wanted to play around with today. By the way, I guess before we should move on, we should dig into this a little bit more. So let's do a describe and get the object, get the full text out of this and see what it says. And then maybe we'll flip over and do some log viewing. All right, here we go. So we're just doing a describe on that control plane object. Okay. And right here, right at the top, it was like it's unhealthy. Okay, cool. I think that's probably, let's see, pre-flight checks, control plane, doesn't have an API server, pod healthy. That's probably expected from the new one that is just being added, as it's still in the process of coming up. So let's see what else is listed in here. If there's anything else important we should note. All right, server-side fields. Okay. So, yeah, okay. Looks like that's just, yeah, okay. See the replicas that we specified in the YAML file here. Okay, and then last events and status conditions, scaling up, okay. And let's see if that latest event is changed at all. Okay, still in the process. Okay. So we'll give that a few minutes. Let's see. Maybe we just, let's see. That's, if I'm not mistaken, that is running out of the kubeadm controller. So let's just look at some logs and see if there's anything we need to be worried about. I don't think there is. Kubeadm control plane system. Okay. So kubectl -n cabby kubeadm control plane system, get pods. And that'll show us the controller manager. Okay, cool. Logs from that and from the manager container. All right, so this is going to show us some logs, and let's see. Yeah, don't see anything that looks terribly concerning here. A lot of informational error messages, just as it's checking, it's waiting on things to go live. So, okay. We'll let it sit there and bake. We don't want to rush things too much. Let's check the status of our other cluster. Let's use clusterctl describe to check the status of our other workload cluster. So Andy telling me we shouldn't be looking at logs. Okay, fine, Andy. I will not look at logs. All right. That's why I'm going to go back and do clusterctl describe cluster. Let's see what it says about the one that I'm scaling up, right? Oh, that's right. I forgot. I specified the version here because I didn't want to replace my main version in case I needed it. Okay. So, okay. It says C control plane objects. All right. All right. That's cool. All right. Let's see where B stands. This is the one that we created. All right. It looks like the control plane is up. So, let's see. kubectl get machines. And we'll check the machines for TGIK 143B, which shows running, and we'll have to pull down the context. Hey, this is where I can use clusterctl get kubeconfig, as pointed out earlier. How's this work? All right, get the workload clusters kubeconfig name of workload cluster. All right, TGIK 143B, and does it output to? Yep, it does. Okay, so let's put that into my file, TGIK 143B. Yeah, that's a lot easier than using JSON path. Thanks for that. Okay. And then KTIX, TGIK 143B. All right. And let's see where things stand here. All right. Well, we do see that the control plane node is up and showing ready, which means that it is probably already running the Calico pods that we saw in the cluster resource set. And sure enough, let's see, waiting for it. Here we go. Yep, there they are. All right. So just to close out the cluster resource set section, right? showing you that we can use cluster resource sets to apply stuff to existing workload clusters and also to catch new workload clusters as they are provisioned, which is super, super cool. So I like that. All right, now let's switch back to the management cluster and check on our control plane objects and see how things are working there. Okay, great. So now we have 2 that are ready, which means that second one finally came online and now it's spinning up the third one. So that's great. Cool. Okay, there we go. All right, so while that is continuing to bake, I want to take a look at machine health checks. This is another feature that I haven't played with. You can see more information about machine health checks here. This is on the Cluster API website, and I have a link for this in the show notes so that you don't have to hurriedly scramble and write it down real quick or take a screenshot or whatever. And the idea here is that this is a way for Cluster API to perform like a health check, right? That similar to what it would do for a pod to make sure that a pod is running and responding and so on and so forth. We're doing this for a machine. And then if a machine is considered unhealthy, then it will automatically sort of remediate that, which will trigger a new machine to be created and then remove the failed one. Here's an example, and we're going to use this example as like just the the starting point for us. Although I think I should probably scale up my number of worker nodes before I do that. So, because with only one worker node, then it's probably not going to do it. It's probably not going to work the way we expect it to. And that's because of this max unhealthy field, right? Although the default is 100, so as long as I change it to 100%, I don't have to do that. Well, nevertheless, let's go ahead and let's see. kubectl get machine deployments. I should have 2, 1 for TGIK. Yep. Okay. I'm just going to scale the number of nodes in that first cluster real quick. Machine deployment, TGIK 143A, MD0. Okay. So this is the imperative way to scale the number of nodes. The declarative way would be to go and modify the YAML like I did for the KCP, and then and that way we have it. The reason there's a difference there is that if I'm not careful, if I'm not paying attention to what I'm doing, and I run this command, and then I go back later on and I reapply the YAML again, then I'll end up undoing what I just did and possibly causing an outage. So generally, I recommend you stick to the declarative way by modifying the YAML. But for the purposes of this, we'll just we'll fly by the seat of our pants. How's that sound? Okay. So, and it's in the process of scaling up, so it's going to do that. Now, let's look at machine health checks. All right, so I copied out the machine health check from the documentation. All right, so here we go. Kind metadata, let's change this name and we'll call it MD0 MHC, machine health check. Very original here. Cluster name, we're going to apply this to TGIK 143A, TGIK 143A, all right. And max unhealthy, I believe we can, actually, let's just comment this out for now, which means it's 100%, which means remediation is always going to occur. Did I read that right? Machines will be remediated no matter the state of the cluster. Right, okay. All right, very good. Saw somebody asking any way to lock the configuration according to declarative manifests. Yes, put your manifests in a Git repo and force code reviews or some other process before people edit them. That would be one way of doing that. I'm not sure if there is a technological way of doing that other than restricting permissions using RBAC on the clusters, which would be one way to do it, I guess. The other way to do it would be to put some process around it, which you probably should be looking at anyway, if you're going to be moving Kubernetes into production. All right, so then node startup time is 10 minutes. This is how long it waits for a node to join the cluster. Which machines should be health checked? So here's where we need to find match labels. So let me save this. All right. And what I'm going to do is let's go describe the machine deployment, because if I recall correctly, then what happens is they automatically get these labels put on them. These machines should automatically have these labels put on them. So I should be able to use those. Let's just copy this one. And let's take a look at kubectl get machines. Let's look at, okay, so the machine deployment is still provisioning, so it's still scaling up. Let's look at the one machine that is running. kubectl describe machine. This one. Make sure that it does get the labels that we saw inside the template. Yes. Okay. So we're going to use this label right here for our machine health check. All right. And I think I already copied that, but let's just copy it again just to make sure. Okay. So then we go back to our machine health check. And we go down here to match labels. All right. And okay. So now we have a set of labels. Now, I didn't mention this specifically, but it's in the documentation. Machine health checks only work when a machine is being managed as part of a machine set, which would also include machines being controlled overall by machine deployment. So similar to the way that deployment manages replica sets, which then manage the number of pods, a machine deployment manages a machine set, which then manages a group of machines. And so as long as you have machines being managed by a machine deployment or a machine set directly, but machine deployment would be better, then you can use a machine health check against that. So I've got the match label here, and then now here are unhealthy conditions. If ready is showing as unknown, or if ready is showing as false, then it's going to say that those is unhealthy. Okay, so let's save this. And then let's see, I need to apply this, kubectl apply. Whoops. Okay. All right, so now I have created the machine health check, and thinking about it now, I probably should have changed the name in case I wanted different machine health checks for different clusters, because MD0 is a generic name that multiple clusters are using. Oh, well, okay, that's fine. And so let's do a kubectl get MHC, and it shows there, and it shows currently healthy and currently max unhealthy. Okay, awesome. Okay, so let's see. I got to think about the best way to simulate unhealthy. I guess I could just go into the AWS. Let's see. Well, yeah, I guess I could go into my AWS console, which I will not be showing you here on screen, and just shut that machine down. Let's see, instances. All right, so, all right, well, first let me look at my machine deployment. Did it finish scaling up? It says there are 3 and that they're all healthy. Updated 3, okay. And then if I do a get machines, okay, it shows they're all running, okay. And then if I do TGIK 143A, and then a get nodes, you can see them all showing ready. Okay, all right. So, drop the timeouts to a smaller value for the demo. Yeah, that's probably a good idea. Andy just pointing out in the chat that because I'm doing this kind of live right here, we don't want to wait 5 minutes for it to detect that it is unhealthy. We would want something shorter. So let's update our health check. So let's change this to something like, I don't know, 30 seconds, just for the purposes of the demo. And then we'll apply this again. And and that'll change it. Oh, that's interesting. Oh, haha. See, this is why it's useful to have your kubeconfig displayed on your prompt. And that's because I have my kubeconfig pointing to my workload cluster. So we go here and then apply it. And then it's better. Okay. So now we have that showing as shorter. I wonder if it's worth setting both of those because I don't know which of these conditions will come up. Let's set this one too. Okay. And then we're going to pick a machine. So let's pick a machine to shut down. How about we go with this one? All right. So MD0 143A. Oh, fascinating. Okay. Then I'm going to have to get the AWS machine ID. Alrighty. So then, which one did we say we were going to do? BMQ4Q. And so we find that one here. And which is actually this one. Okay. So right here, we're going to stop the instance. Okay. Okay, so that instance is now stopped. And it'll take a little bit for the system to update. But what we should see here soon is that it'll detect that the machine is unhealthy. And then we'll see MachineHealthCheck kick in. We'll give that a moment. All right, while that is happening, let's check in on our other workload cluster that we created. Okay, so TGIK 143B shows provisioned. All right, we've saw all the machines right up above that and to show that they're running. So let's run our clusterctl describe again and show what it says. Describe cluster TGIK 143B. All right, and it shows that everything is up and running and everybody's happy. Awesome. And we already saw that the CNI got installed properly when it applied the cluster resource set. Just refreshing my, nope. Okay. Okay, here we go. All right, the node that I shut down is still in the process of shutting down. So that's probably why it hasn't detected that it is offline yet. Okay. Oh, cool. Awesome. Check that out. Okay. So BMQ4Q was the one that we shut down. And notice that Cluster API is showing that as deleting. And it is automatically provisioning another one. So that is cool. That means, as far as I'm aware, the MachineHealthCheck worked as expected and therefore detected the machine was unhealthy and automatically started provisioning a new machine, which is super cool. I wonder if there's a way for us to look at that event. Let's see, describe MHC, MD0, MHC. Let's see if it shows us on the events. Targets, remediation allowed. No, it doesn't. Okay. But if I were to get the machine deployment, it might show us that. Or I could look at logs, but I'm not supposed to look at logs. So we won't do that. Okay. So we've seen 3 new features in Cluster API so far. We saw the cluster resource set, which allows us to automatically install new and cool stuff. Automatically install things like CNI or a CSI driver if you need to install a CSI driver or other things. Maybe you need to define storage classes or something like that. You could do that with cluster resource set. So we saw that. That's very, very handy. I'm going to start using that quite a bit since I do a fair amount of workload cluster provisioning for testing and stuff. And it's always a pain to have to go back and install the CNI afterwards. So that's cool. We also saw the KubeadmControlPlane or the KCP, which allows us to treat the control plane object as a single object. And then we can just scale that, right? rather than having to say, okay, I want to provision 2 more machines that would then, be spun up and bootstrapped as control plane nodes. Instead, we just treat that whole control plane as one object, which allows us, again, to easily scale the control plane up or down. Although scaling down, again, be aware of sort of the caveats of running a single control plane node. And then we also saw machine health checks, which perform health checks against machines that are being managed by a machine set. So if you define a machine individually, which you can do is just define a machine in the cluster API YAML, that will not be subject to checks by a machine health check. Only machines that are part of a machine set will do that. And then it will automatically remediate those. So if it shows up as healthy, then shows up as unhealthy or is detected as being unhealthy, then it'll automatically provision that. So let's do this. And okay, I need to get machines. Notice here that it shows 2 ready, 1 unavailable. Fabrizio just pointing out the machine health check also works now with the control plane machines being managed by KCP. So that's very cool. Which means you could define machine health checks to check your control plane nodes and remediate those if you wanted to. Let me get my list of machines here. Okay, so now we show all of the machines running. And if I flip over to my AWS console, let's see, I show the one that I stopped now is terminated, not just stopped, and then it spun up a new one. So that corresponds to what we saw on the screen just a moment ago, which was Cluster API deleting the machine and then spinning up a new one. All right. So, all right. And then, let's see, let me check the live chat here. Marco's asking, no way to assign a single machine health check to multiple clusters. As far as I am aware, yeah, machine health checks are going to be per cluster, because when we looked at the YAML for there, we had to specify a cluster name, which then associates this machine health check with a particular cluster. Now, conceivably, I guess you could, maybe if you played around with the match labels, you might get it to be able to match multiple machine deployments. But no, it appears to be per cluster. So you'll have to define different machine health checks for each cluster and then store them appropriately. Okay, so all right, well, thanks for Andy just taking off. Thanks for being on, Andy. I appreciate that. Super helpful. Okay, that is everything that I had to show all of you. Let's see. We saw that the machines were up and running. We saw the KCP. We saw the control set. I think that about does it. So I will make sure that the show notes have links to all the resources that I showed you. So we saw this one on working with machine health check. This is off the Cluster API website, and that's already in the show notes. And then working with ClusterResourceSets is already in the show notes as well. I did note that the update to the documentation for clusterctl describe has apparently not hit the website yet. So we don't see clusterctl describe here. There is get kubeconfig, which I just completely missed. I don't know how I totally missed that, right? But this greatly simplifies the process of getting the kubeconfig for a workload cluster. So that is, that's going to make my life like so much easier now. I can't believe I totally just didn't catch out on that. Anyway, but okay. So that's, I think that's it. That's all I have. I know we're probably a little bit shorter than perhaps some episodes, which run a little bit longer, but hopefully all of you have found something cool out about Cluster API. I learned some stuff today. Hope you learned some stuff. And then, this will be posted on the TGI Kubernetes YouTube channel for on-demand viewing afterwards. So feel free to, pick it up later on in the event that you didn't get a chance to watch it live. And then again, the show notes are going to be updated with links to everything and all of that. So, all right. I think that's it then. I will see you all next time. Hopefully I did a good enough job that Joe and the rest of the TGIK crew will invite me back, because this was a lot of fun. So I hope I get to do it again. And in that case, I hope to see you then. So bye, everyone.